Right, question 7, part A. Rewrite this integral then as 3x to the power half. Okay, and then minus 2, then we'll take that x to the power 5/3 up, so it becomes minus 5/3. And then when you integrate this, then you get 3x to the power 3/2, so we add 1 to it, divide them by the new power, take away then 2, when we add 1 to minus 5/3, you get minus 2/3, divide them by that new power, minus 2/3 plus c. So let's tidy this up a little bit. Take the 2 up, so you get 6/3, so that becomes 2, x to the power 3/2. Take the 3 up there, I missed out the x there, haven't I? Take the 3 up there, so you get 6 over 2, which is 3, and of course minus and minus make a plus, so that will become 3 x to the power minus 2/3 plus c. Okay, one thing I could do then, of course, is just to take that x to the power minus 2/3 back down, and there's our final answer. Okay, part B then. Let's look at part B, what it's asking us to do. It says the diagram shows a sketch of the curve and the line. The curve and the line intersect at the point A in the first quadrant, and the curve intersects the positive axis at the point B. Showing your work and find the coordinates of A and the coordinates of B. Okay, so when we work out the coordinates of A, it's where this line and curve intersect. So when we've got here then, we've got the curve which is y equals 36 minus x squared, and the line which is y equals 5x. Now where they intersect, of course the y values will be the same, the x values are the same, but the y values are the same, are going to help us. So we can put them equal to each other. 5x equals 36 minus x squared. Get everything onto one side. X squared plus 5x minus 36 equals 0. Okay, so 2 brackets, and you've got plus 9 minus 4 equals 0. Okay, so then when you solve this, then x minus 4 will equal 0, or x plus 9 will equal 0, so that means x equals to 4, or x equals to minus 9. And we need to see which one satisfies this. Alright, clearly you can see what we've done here. We've solved when the line and the curve intersect, okay, and you come up with two answers, x is 4 or x is minus 9. Now common sense tells you that there is where x is equal to 4. Okay, minus 9, well, it comes out because actually the line and the curve will intersect at some point down here. If we kept on going, that line kept on going, the curve kept on going, it would intersect when x is minus 9, but that doesn't interest us. It's not important. This is what we're interested in here. So and again, read the question. It says the coordinates of A and B. So we've got the coordinate there of A, the x coordinate, but we need the y coordinate as well. So y will equal then, if we just use this, 5x, so that'll be 5 times 4, which equals to 20. So therefore A will equal 420. Okay, now for B, right, for B, now we're just focusing on the curve here. If you think about it, it's got nothing to do with the line. The line is on its own there. It's where the curve, and if you think, it's where the curve intersects with the x-axis. So on the x-axis, okay, on the x-axis, of course we know that y is equal to 0, right? Y is equal to 0. So when we get the curve and put that equals to 0, we can get the answer out for x. And it is important you use the curve, remember, not the line, because it's the curve here is when we're interested in, when it cuts the x-axis. So you basically set the curve to equal 0. So that means x squared is 36. So that means x will be, take the square over a square root, plus or minus square root of 36. So then x will equal plus 6 or minus 6. Okay. Now, quite clear here again, this is obviously where it's equal to 6, okay? It's equal to minus 6 over here, but that doesn't interest us. So we could say, therefore, B will equal 6, and then of course 0 will be the y value. So there you go, we've answered part 1 there. So for part 2, okay, part 2, we need the area of the shaded region. And let's think carefully here. Actually, this line is going to really help me here, because if you notice, this line splits this up into 2 parts, and you need to think of it as 2 parts. Call this sort of A1 and call this A2, and you realize A1 is just the area under the line, okay, right? Nothing to do with the curve, just the area under the line, but A2 is purely the curve, isn't it? So we could work out A1 here, area under the line, once with our answer then, and then our answer for A2, area under the curve. Of course, we need to combine these, okay? We're not taking away this time, we're going to be adding them to give us the combined area. Now A1, okay, is actually really easy. If I write down the A coordinate there, which I worked out earlier, didn't I? I worked out to be 420, okay? I can actually think of A1 as a triangle, and it would probably be much easier to do it that way. It's slightly less work than integrating. So A1 would equal half times base times height. So the base is 4, and the height, of course, then will be the y value, which is 20. Okay, and I get that out then to be 40, so that comes out quite quickly. Okay, A2 I will need to integrate between 4 and 6. Okay, so A2 will be the integral of 36 minus x squared between then 4 and 6. This becomes 36x minus x cubed upon 3 between 4 and 6. So we put in those limits then. Okay, so we put in the 6. So we've got 36 times 6 over, well, that's it, isn't it? It's not over anything. Take away 6 cubed over 3, and then take away then, let's put the 4 in, 36 times 4 minus 4 cubed over 3. Okay, so we'll work that out on my calculator. So we've got 36 times 6, take away 6 cubed over 3 minus then big bracket 36 bracket again was 4, take away 4 cubed all over 3, and then close the big bracket, and I should get my answer out to be 64 over 3. Okay, so remember now you've got your A1 and A2. The total area then will be those two combined. Okay, so total area equals A1 plus A2, which equals 40 plus 64 over 3. And if you do that on your calculator, plus 40 from the answer from before, you get 184 over 3. And we've got our final answer.